Hi everyone, welcome to this talk where we're going to have some fun with legacy code. So the goal of my talk today is that each and every one of you will feel inspired to go home and test your legacy code, and that each and every one of you will have a feeling that, yes, I know how to do that, I can handle that. So my name is Opheim. I work as a tech lead for a Norwegian consultancy company called Kompetas. I've also been a developer for years. I'm still developing, having fun with that. And I'm definitely working on a project with legacy code. Like, how many of you here do feel that there's not much legacy code in my project? No one? Okay. Yeah, one or two guys. Let's go. You are lucky. So maybe not everything I'll talk about today will be directly applicable to your project, but I think that the underlying ideas, the underlying ways of thinking are relevant to every legacy project. All right. So, but the title of the talk is 9 ways to test your spaghetti code. So what is spaghetti code? Oh, this picture doesn't look good at all on the screen, but it is boiling spaghetti. I made spaghetti while preparing this talk. And when I had a look at the boiling spaghetti, I saw that, oh, this is unclear. It's hard to see what's really here, how things are connected. But also, everything was intertwined, everything was tangled together. So it was hard to see, okay, if I touch this part of the spaghetti, then it will affect this part, or maybe this part, or maybe this part. And that's pretty much the same as the situation typically is with legacy code, right? You don't really know if you change something here, what happens over here. All right, so a precondition for testing your spaghetti code, though, is my assumption that we as humans, we are flexible, we are creative, we are able to figure out workarounds, do things in different ways, handle things differently. While the computer is, by its nature, stupid, right? It follows a recipe. It says it does this, and then that, and then that. And if some of that fails, we don't know what to do. But on the other hand, we as humans, we are bad at doing the same things over and over again and expecting the same results and keeping the same attention every time. Yeah, we might stay focused the first time, but the second time or the third time or even the fourth time when you're manually doing a regression test, you will be bored, right? Your mind will inevitably start to wander. You will lose focus. Such things don't happen to a computer. The computer doesn't get bored. So, and that leads us into the idea that, yes, it's definitely right that the computer should do the automated testing. And we as humans should use our creativity to do exploratory testing or to figure out new things to test or program or develop. Or there are lots of things we should be doing instead. So now I'm going to walk through 9 ways or techniques that can help you to actually test your legacy project, your legacy code. So let's jump directly into tip number 1, extract interface, right? I assume, by the way, that many of you do program Java or similar languages. And in Java, when you extract an interface, you make the API that you're exposing to the surrounding world, to the people using your code, or to the other developers in the project, you make it very clear to them. Like, okay, this is the method I'm exposing, or these are the methods I'm exposing. I suggest that you call these ones with these parameters, right? And you hide the implementation details that you don't necessarily need to know all the time. And it also makes it possible to minimize the API and make it clear. And here are 2 examples from the project I'm working on for Norwegian courts. Up to the left, you can see the implementation. You can see that this has 8 methods. This is not that bad class, but still it has 8 methods. And when you see these methods, you start to think, okay, what does this method do? What does this method do? Which one should I call? How are they connected? And so on. Those parts that you probably don't understand are in Norwegian, by the way. While down here, you can see the interface. The interface, it has one single method. And it exports and it really tells you that if you want to use this class, okay, call this method, done. That's all you need to know about it. So if you're testing this, if you're testing a caller of this class, it will be so much easier for you if you see this one and not that one. All right, tip number 2. Yeah, still on like pretty general tips, but set your dependencies from the outside. Use inversion of control in some way, like either with setters, with injection, or constructed with parameters. I like CDI very much, so I tend to use that when I can. And this is also a simple way to untangle, right? To tear those dependencies, tight dependencies apart. So, yeah, here's an example of that. Just normal plain setters, which are annotated so that the app server will inject them for you in production usage. But also in your tests, you can call these methods with some object that you have control over, right? Not necessarily the real object, but something you can control. Like we do, here's an example from our tests. Some of the tests, you just call these setters in your test. Done. Yeah, another example. And here we are more on the legacy part, because you see we have lots of dependencies. So this class called dokumentvarsling, that's document notifier in Norwegian. It probably does way too much, but hey, it's legacy code. You can do this. It's not a big deal. All right, singletons. Yeah, don't fire me. I'm not taking a stand at the singleton pattern per se, right? Some of you might like the singleton pattern, some of you might dislike it. Both ways perfectly fine with me, but if you do have singletons in your project, like many do, right? Then you should know how to test them. Because there are some challenges that occur when testing with singletons. Here's what you can do. Just call the setInstance method with your fake code manager and your test. And then you're done with it. And this works fine as long as you're not taking into consideration things like threading, parallelization. You might want to have fun with things like fork count and do things in parallel. These are things you should consider when testing legacy code. When testing using singleton pattern. Because you won't get rid of it for some time anyway. Yeah, tip number 3. Sorry about the title, I couldn't resist. The package protect problematic parts. This is a trick I use a lot. So if there is something in your class, in the class you want to test, that is problematic, right? That writes to the file system or does a network call or shows a GUI window or anything like that. Extract exactly that part into its own method, make that method package protected, and override it in your test. Yeah, I know it sounds simple, but many people don't consider this, and even though it sounds so simple, it's a trick I use very, very much. Like, the more legacy the codebase is, the more I use this tip. And yes, it is an indication that your code is not divided properly. But by extracting it such, you also make that clear and visible. So the next time you come and see it, you can see, okay, this class has too many responsibilities, but it's explicit to me. So now I know that. And then you can take that into consideration when doing further refactoring. Yeah, Mockito is a great tool for testing. Can be easily combined with the previous trick. I guess people have strong opinions on Mockito as well. I met many people who has. It might be a useful tool. We're using it at the project I'm at now. It works pretty fine. Of course, you can overuse it. With Mockito, you can create objects that are totally stupid, that you can totally control yourself, and you can make assumptions on them. So you can say that, okay, verify that I've never been called with these parameters, or that this variable hasn't been called at all, and things like that. You can do with Mockito. You can also do very much with Mockito so that you get totally lost in your test and totally forget what you're trying to do. Don't do that. So use it with sense. And there's also similar tools in things like in languages like Kotlin and C# at least, and probably many other languages as well. Yeah, consider removing final. That's also a tip. I don't know how many of you guys really like final, but those who tend to like final like it a lot. So if you're saying that a class or a method is final, then it can't be overridden in the subclass or in the mock. So you cannot really use Mockito on it, as we just saw. So if you're having trouble testing some class or method that is final, remove final, which makes it easy to test if you have that trouble. Or refactor more, but that's an easy way to get started. So a conclusion we can take from what I've been talking about so far is that well-designed code tends to be testable code. And that also, while the design is better if you use the single responsibility principle, or the design is better if you use dependency injection, I would also argue that it's better if the methods are short. And each and every one of these things also makes your code more testable. And that's, yeah, the same with providing a clear API. And after all, to test legacy code, to get legacy code under test, is to a little degree about testing. It's mainly about three things. It's about the will to do it, it's about patience, and it's about your production code. Like your test code should be simple and easy and like technically boring. Your production code should be designed and made up in such a way that you don't need to create very smart or fancy tests. Okay, tip number 5, help your team. And this is a warning, could I say, to if like some of you feel like, oh, I'm gonna be the rockstar developer that tests all the code. No, you're not. It's fine. It's great that you are testing the code, but if you are in a team and you're the only one testing code, then that wouldn't be enough. So get your team with you, and make it easy for everyone in the team to write the test. Because the easier it is, well, the more probable it is that people will actually do it. And if it's a lot of hassle to get that, even get instantiate a test class, then people wouldn't do it. At least they wouldn't do it unless you force them to do it, and that's not a great way to work in a team either. So make it easy for the entire team. Yeah, run your tests and care. The last part here is important. And I assume that all of you already do have running CI servers, running your builds, Travis or Jenkins or TeamCity or whatever. And I also assume that these builds run your tests. Whether you have like 2 tests or 2,000 or 20,000, yeah, but that they are running. But also make sure that you care about the results of running your tests. I can admit that at our project, we have had some situations where we got some tests failing, and we didn't fix it immediately. And that was a major mistake, because then people started losing trust in the tests. And when you have one test failing, people start losing trust in that your tests know what they're doing, kind of. And then the second test start failing, and no one notices because the build was already read, right? The tests were already failing. And now we have another test failing, but no one notices. So if you have a failing test, handle it immediately. And yes, it might be the production code that is wrong. It's a real bug. Or it might be the test that has some weaknesses, like hard-coded dates, or strange things like that. Or it might be a stable network or anything like that. But make sure that you handle it so that if a test fails once, it won't fail in the next build. And the same goes with flaky tests. Those tests that fail every 5th time, every 10th time, whatever. These type of tests, yeah, they're a real challenge. And if you have them, people also will start losing trust in the tests. So your tests should be entirely stable. They should always give the same results. Like this should be, as we started with talking about, they should produce the same results every time. They should be predictable. And you might have to use some time to actually handle the flaky tests. But you'll regret if you don't. So take that time. All right, tip number 7 to test your code, feature toggles, right? And this is kind of a trade-off, like feature toggles usually is. Because with a feature toggle, you can say that if this and this condition is met, then do this. Otherwise, do this. All right? And it can be fine for A/B testing, for introducing new functionality gradually. But it can also be fine for your tests. Like in this example, we say that, oh, if we are running headless, as we are doing with our tests, then run the code at once. If not, invoke it later when Swing wants it to. And this is kind of stuff that you don't really, ideally, wouldn't want to implement in your code. But sometimes you have to make trade-offs. And by doing it this way, we ensure that our tests are stable, right? Because we can't trust Swing. Well, you can hardly trust Swing for anything, but you can't trust it to run this thing at once. Yeah. Okay, so one idea from my side, though, that one class, the typical pattern is that if you have one production class, you write one test class for it, which is usually fine. For most cases, that's fine. But in legacy code, things ain't always fine. So you might have a production class that has several groups of responsibilities, right? You can have a production class that has 8 methods handling persons and 8 methods handling organizations. And the refactoring needed to split it is too big or too risky for you to do it right now. But you can still perfectly fine create 2 test classes, right? One test class for the person part and one test class for the organization part. That's perfectly fine, and that's also pointed a direction for further work on the code, for further refactorings. And that's also a tip I want to share. I think it's really important is that you do the refactoring all the time. You refactor every time you code something. You can say that it is the Boy Scout rule, right? That every time you leave the code base after doing a change, it looks somewhat better than it did when you started. And if you continue doing that all the time, you will get to a better place. All right, tip number 9, do test-driven development. And when I said that to people working on legacy projects, they say, oh, you can't do this TDD here, it wouldn't work. So I did it, and it worked. So what's so cool about test-driven development? Let's just swipe shortly through that. It's that, well, you write tests, of course, and you write tests without hardly ever noticing it because it becomes a natural part of the way you're working. But also, at least for me, I tend to write easier code when I'm doing TDD. Like, if I'm not, then I'm hacking and doing things and writing lots of code, and then I get all the pain afterwards in trying to test it. But here I only create, when I'm doing TDD, because I write the test first, I'm too lazy to make all that things in the production code so that I have to make lots of things in my test code. So it prevents me from writing lots of unnecessary code. And living in a legacy system, things like building, compile, startup time, when launching an application, maybe a long time, maybe at least several minutes. Right? But if you're writing a unit test, the feedback comes to you in a second. And having that immediate feedback, it's so valuable. So tester in spaghetti. How do you do that in a recipe kind of way? Well, what I tend to do is if I do change an existing method, though, if I write a new method, then it's of course no problem. But if I do change an existing method, I start by getting that method under test as it is. I write a test class and I write a test for that method. And I might have to use some of the techniques we'll be talking about, like externalizing dependencies and extracting interfaces and those kind of safe refactorings that your IDE can do for you. So I do that, and when I do have a test that just runs through the method and runs green, then I do the assumption on the thing I want to change. And then I run the test again, hopefully it's failing. And then I fix it by changing the production code. Run the test again, and it's green. So now we have changed the code. And then you do refactoring, right? You might want to do more refactoring as well. And the single technique, I have to say, I use the most when I do TDD on spaghetti code, or even legacy code in general, is to split things up, because the problem typically is that things are so tangled together. Yeah, so the short version, if you want to do TDD on legacy code, you have to do two things. You have to do TDD, and you have to use the proper techniques to test legacy code. And you combine those two. And that's all that is to it. All right, so that's a short run through of techniques to test your legacy code. And if you are interested in more or need more tips or more techniques, where do you head next? Well, these two books I totally recommend. I read them both and had lots of usage of that. The first one to your left, Working Effectively with Legacy Code by Michael Feathers. Yeah, it's a 15-year-old book or something, but most of the tips are still very usable, very applicable, directly almost. The second one, I would wait a couple of weeks to buy, because it's coming a version 2 of it, Refactoring by Martin Fowler. He's actually launching Refactoring version 2 just these days. I think I saw next week that they started selling it. And also, head on to Twitter. On Twitter, Lisa Crispin, Lizzie Hockey, Angie Jones, and lots of test gurus are there. They are sharing ideas, sharing ways to do things, sharing their knowledge. I've learned a lot from that. And there are many more test gurus on Twitter, but if you head on to these people's profiles, you find the other people to follow. Yeah, so if you want to take away 3 things from my talk, I'd say these are the ones. Good design improves testability. The second one, short-term sacrifices are okay, because in the long term they show you the direction for a better code base, for a better situation. And the third one is the most important one. I urge you to write tests for your legacy code, and I do believe that you can do it. You can do it. It's a question of will, patience, and using techniques when you need them. And you know how to do that. You're great programmers. So go home, or preferably go to work, and test your legacy code. Спасибо.